Hello, hello, everybody. Welcome back. I hope you're having a great day so far. Let me get these chat docs loaded up here so I can see everybody's chats. All right. Cool. Welcome back. Sorry I'm a little late to getting this one started. I was taking a nap and I just was having a really hard time getting up. I was struggling. I just took an airplane back home today and was up early, and so I just needed to rest up for a second, and now we're all good. Geodasher, welcome. That's a new name I haven't seen so far. Hey, glad I caught the live. Hello. Welcome. It's great to have you back. How you doing today? What's going on? Mahan, welcome. How's it going? Welcome back. We are here back in our normal setup today. We got the lava lamp going. We are ready to go for today. Welcome into Steel. Welcome back, Dat Steel. Appreciate you coming in. All right. How you guys doing so far? Okay, let's go ahead and let the Discord know that we are live. Here we go. Give me a second here. Here we go. All right. Oh, so sweet. All right. Geodasher says, "What kind of project are you working on?" All right. Yeah. So, um, those that are new catching the stream for the first time, this is the normal format. Is that in the beginning of the stream we work on some additional learning, and then in the back half of the stream we will work on our small business manager project. So for just to answer your question, Geodasher, the small business manager project that we're working on is a inventory system for items for some sort of business related inventory. We have various attributes associated with each item, and then we have various attributes that we need to fill in later on to quote unquote convert these items into sales, for sales, and into sales. So our program so far, just to give a little demo before we jump into the learning, is that we can have this menu. We can load inventory items in this menu. We can find them and edit them in our database. We can transact them. We can view the inventory. If we go back, and then we can go into our transactions menu, and we can transact these items into these sales, right, so far. So little by little we've been adding features on it here. Hopefully we'll get to a point where we can take in like expenses, um, maybe even auto sync up expenses somehow, or would be really cool. We could take in expenses. We can then relate those to the sales and revenues, cash flows, and sales, right, to determine like a profitability factor, and then generate reports based on that information and provide those to the business owner. This is mainly a tool for small business owners because maybe a lot of small, personal sole proprietorship businesses aren't, super well equipped or have the knowledge to, deliver these types of reports and track this inventory. It's not really taught that well in American education systems, right? But the American dream is to become a business owner, but yeah, you never taught how to, which is kind of funny. So, anyways, this is a kind of a cool tool that we can provide to small business owners, like through GitHub, probably for free eventually when we finish it, to allow them to have all these resources at their disposal rather than having to come up with something on their own. So really, really cool. Yeah, but this is what we work on in the back half of the streams after we do our learning and and then we implement our, our learning and our continued development into our project here. All right. Mahan, practicing some back end stuff. Awesome. Yes. Good, good, good. We're all practicing some stuff together here. Hey, General Talks. Yes, we're back from vacation here. It was a great time. Spent with my parents and my family just hanging out over Christmas, doing some fun things. I went to a basketball game last night. It was really fun. I actually got to go out on the court and get a t-shirt from one of the players. I was selected for that, which is the whole purpose of why I went in the first place. It was like like a Christmas present from my parents because I was a pretty big fan of that team growing up, and yeah, it was fun. It was a good time, and it was cool. Um, all right, helpful lamb 680. Hey Michael, found you through the YouTube algorithm. I had a lot of fun watching your previous streams. Oh, awesome, helpful lamb. That's really great. I was wondering if people, watch the replays. Like, do they, how much value do they get out of the replays? And I wonder, like, if people like listen to them like podcast style, like at work or something, like or whatnot, just in the background. So that's really awesome that you're enjoying the replays. That's super cool. Thanks so much, and glad that we caught you live here. Yeah, so for those that don't know, I just past couple of days I was just on vacation, so my streams were a little bit all over the place. But on my normal stream schedule, I stream every day from around 7 or 7:30. Today was a little bit later. I got up from a nap a little late because I was traveling, but I stream every day after my 9 to 5 job, Monday through Friday, and then on the weekends some other times. But today is Sunday, so it's kind of a little bit different. But 7:30 to around 9:30, 10, 10:30, 11, 11:30, depending on how long we want to go. I usually try to do a minimum of 2.5 hours a stream, just so we can see everybody, get everybody in here, and yeah. But on the weekends I'll come on earlier and stuff. Just this one was a little bit abnormal. But I appreciate you coming in. I ain't gonna lie, Python is starting to annoy me. When I was making a Discord bot, the script worked, but now when I try to make another one with the same imports and all, but adding different stuff. Oh yeah, it can be frustrating for sure. Yeah, I watch the replays in the background while I build stuff sometimes. That's really awesome. You guys are really cool. That's really sweet. Okay, so last time we left off on problem 6.13, and we solved this problem, but I think we solved this incorrectly. Um, because, right, we are doing a pop zero. I don't think I can do this. Instead, I need to say dot insert to capture, um, so we need to, no, that'll pop zero. Okay, so, no, okay, if you remember back, you guys, we were dealing with dex and we were dealing with q's. Um, Give a code fragment D and Q were, yeah, so we had to swap these two values, and we were able to do that here in this program, but we were using a pop zero here for a Q, and I just I don't think we're allowed to do that, right? Because a Q you can only remove from the end. Because which is a little bit frustrating here. My mouth's really dry. Okay, so because we solved this already, I wanna take it just directly into the Almighty Orb and be like, I solved this problem, but I realized I am using a dot pop at 0 on a for applied to a Q, variable Q. You're correct that pop 0 is not an appropriate Q operation for a Q. It has a time complexity of O(n) for lists in Python, defeating the purpose of using a Q. Instead, Q should follow the first in, first out principle using collections.dec for the O(1) operations. So they convert my Q into a dec as well, and then they use the pop left method on it. Okay. So because Python doesn't have a Q inside of it, they just, and we wouldn't even need this Q because it's empty. So it'd be Q with a dec here, right? And so rather than popping 0 here, we would just q dot pop left. And that would have the same kind of general effect, right? Because we'd have to also pop. Would that give us the same answer? No, because we need to remove this and take out this guy. And then let's see what that gives us. Okay, cool. That gives us the same answer. Okay, cool. So they have this also while Q here to help kind of be another, like a better checker, because if there is, there will be Q in this problem, but it's probably more um, Pythonic to just say while Q rather than just calling the function defaultly, like on any sort of instance loaded in. Even though this specific one, we know it'll work, but then we'll return list D. Okay. So they use the q.pop left. All right. General Tuck says, "Hey, can I suggest you something? I think you should try regex. It helps you on input validation faster too. I will definitely recommend to learn it." Yeah, definitely. In the CS50P course, there was a whole week on regular expression, so I'm a little bit familiar with it. I would have to refresh my memory, but I haven't found too many like instances of where I'm needing to require like for instance, like an email address or something like that. I mainly just been using like numerical input values, so it's been pretty easy to manage so far. But yeah, that's definitely a good idea to get into. Winghong says, "Oh, hello, welcome back, Winghong." All right, so this is right. They also have a pop left here. So what would that do? So while this would give us the Q pop. It would need to be pop left. It doesn't really. Well, we would append onto Q the D pop left, so it would take off all of these, and then we would take one by one and pop and append D. I thought that would make things. That would pop off the 3, the 2, and the 1. Oh no, because we're doing it in the same while loop. Yeah, so it wouldn't matter actually, but it's probably better practice to say pop left, even though it's just happening initially, right? But I don't need to say pop left. It can be just a pop. Okay. All right. Hey, Script Serpent, welcome back in. How you doing? Oh, you've been here. Yeah, that's right. Loki Creates says, "What PDF are you using?" Yeah, so this is the Data Structures and Algorithms in Python PDF. We've been reading aloud all of the chapters live on stream. We've read up to through chapter 6 now, literally word for word, line by line, example by example. It's been a lot of work, but it's been very rewarding. We've been getting a lot of knowledge, and we've been able to solve these problems because we're actually learning this stuff really in depth. So which has been really cool. We're about to jump into chapter 7 here. I only do the reinforcement problems just because there's a lot of end of chapter problems. But we're about to jump into chapter 7, which is linked lists, after we finish one more problem. But this is data structures and algorithms in Python. If you want access to this, you can either just look it up online, or I provide all of my study resources linked below in my Discord, where you can join for free and chat with me offline, get access to all the resources, my notes, everything. Get access to other people's current CS majors have also posted their personal notes in that Discord. It's been really cool. Tip the landlord says, "Why are you switching to software development?" I don't think I really am. So for those that don't know, my name is Michael. Welcome if you're here for the first time. I've been streaming every day for the past like 3, almost 4 weeks now, trying to just teach myself Python pretty religiously here, I guess, for lack of a better word. I have been learning for the past 6 months, but been for the past about 3 months been taking it more seriously. I started with Harvard CS50P, where I completed that over the last this summer of 2024, and I started this channel in September of 2024, where I've been kind of casually uploading, and then for the past 3 weeks, really ramped up my studying. Um, it's been really rewarding. For those that don't know, I graduated back in 2021 with a Bachelor of Science in Human Biology and a minor in Chemistry. I work as a formulation chemist for a biotech company where I make biological controls, which are just basically vials of solutions that are used in testing patients and like live samples for both in vitro and diagnostic purposes and things like that, clinical. Whoever needs the product really. So, for example, if you have a sick patient and you're trying to get accurate levels for a certain disease that they might have or you're suspecting, you have to run a control against it to verify the validity of the machine and calibrations that you're working with per like FDA regulations and things like that. And I actually am the one that makes those controls, and they're sold in mass to various hospitals and institutions and things like that. So it's a it's a pretty cool job. But I've been teaching myself Python because I just want to further level up my skills and become a more viable candidate just in general and just a very more educated person. I think that education is a pretty great privilege that we have. A lot of places around the world limit the amount of education you can get to try to maybe control you or for other factors that we won't get into. But we're fortunate enough, or I am at least, to be able to independently study this on my own. And the internet is just giving us all these resources. And to be honest, college, all it is just a reiteration of all these old textbooks over and over and over again for these high fees. So, why would I kind of did the pro and con of why should I go back to school really when I can might be able to just learn the material pretty well through just reading these books and grinding through it and documenting my progress along the way and having other people follow along and either gain motivation, learn as well, and or just kind of hang out. So that's kind of my spiel. I appreciate you guys joining me today. If that's something that sounds like really interesting to you or something that's like something you're interested in, right? Just feel free to follow along, and it's great to have you. And join the Discord link below. We have a lot of great people that come in here every day. Whew, that was a lot of talking. um, all right, let's keep on. So this one, we solved this one, right? So originally we were calling a pop zero on a queue, but we needed to convert the queue to a deck because we need to use it as like a adapter um, class for because Python doesn't actually support queues. You have double-ended queues, and so we needed to convert the pop zero into a pop left to make this more appropriate for a queue. So, but it was really cool that we were actually able to recognize that and up front, and then just on our own we were able to see that, oh, we were doing this incorrectly, and we were able to solve it. So it's really cool. Hey Ruby Kim, this is Data Structures and Algorithms in Python. It can be found in my Discord linked below. Completely free, yeah, no worries. All right, let's move on here to R 6.14 underscore key.py. This is going to be the last problem of chapter 6, you guys. I only do the reinforcement problems just because we have a lot of material to get through here. But we are cruising. We're on page 273 of 770. So we've made a lot of progress so far, and we've definitely learned a lot. Okay, repeat the previous problem using the deck D and initially empty stack S. Okay, is there a stack class in collections? No, Python's collection module doesn't include a dedicated stack. However, you can implement a stack using the deck class from collections because it supports efficient append and pop operations from both ends. You just have to know it's a stack. Okay. So if we wanted to repeat the problem from the before, where we have some, right? We have some deck D, and we want to swap the numbers 4 and 5 using some stack S. So we have to initialize the deck D and a stack S. D is equal to, we'll convert deck of the D they provided. And then we're going to call stack S is equal to a deck as well, right? We just need to keep in mind that this is a stack, so we can only pop from the end and add from the end. Hello, Gino. Welcome in. Okay. So what's our first step here? Let's think back. So we had, while D at index 0 was not equal to 4, we removed from the deck and appended to the stack, and then we removed from the stack and appended back to the deck. So none of this is going to change, right? None of this is going to change where we take the stack, we append or we push onto the stack the D pop left value, and we take the D append, we append back onto D or push onto the deck the Q or the stack pop, right? So none of that will change. That are currently our stack will look like, our deck will look like this. Now we need to say while D at index 0 does not equal 6, right? Yeah. While it does not equal 6, what we're going to do is okay, so we need to pop, or what order do we want to take this out of? So we need to pop left on the deck, and then so I did a Q append on pop left, and then I appended the pop outside of the loop. So this popped off 4 and 5, and then this appended 5 and then 4. Yeah. So this will be stack dot append D dot pop left, right? We're gonna do that. That's gonna take the 4 and the 5 off, and then we're gonna take outside of here. It's not gonna change any as well. It's gonna say D dot. We're gonna push back onto the deck the S dot pop. So that's gonna take the 4 and the 5 off. The 5 and the 4 off in that order. So now our deck should still look like this, right? Now, while D does not equal to 1, right? The only thing is here is we're popping left on the stat on the Q, and we can't do that this time around. So while D does not equal 1, while D at index 0 does not equal to 1, right? Justin, welcome in. Hey man, it's been a week or so. How's it going? Any new changes? Yeah, we've made a lot of progress here learning about some data structures of stacks, decks, and queues, and it's been really fulfilling here. We've learned a lot. Welcome back. Okay, so while D at index 0 does not equal 1, so for the 6, 7, and 8, we're going to pop left, stack dot append the deck dot pop left. So that'll take the 6, 7, and 8 off in that order onto the stack. And then we need to, so that's the problem, is we can't take the 8 off and append it, the 7 off and the 6 off. We need to get this 8 in the first position, the 7 in the first position, and the 6 in the first position. Or in the third position, I mean. Hmm. Um, so right, the 6, the 7, and the 8 are going to get pushed onto the stack, but we can only remove them in that order of 8, 7, 6. So, hmm. Do you think I would have to go in reverse order than in the previous problem? Because I'm using a double-ended Q or a Q, would I have to think about this in reverse order and start going backwards first from -1? So I would evaluate at -1 the value until we got to 5. So what would that look like? So while D at -1 does not equal to 5, right? So that we're going to take off we're going to pop the 8, 7, and 6 off and append them, push them onto the stack. So our stack at this point is equal to 8, 7, and 6. So then we need to D dot um, append left the pop value from S. So that would take the 8, append it onto the deck on the left side, 8, 7. No, we need to pop. So take the 6, put it here. Oh, this is tricky. So if we were to, so stacked out append, we pop off from D. So we would pop off the 8 and save it in the stack, pop off the 7, and this is what our stack would look like, okay? We will then pop off from the stack the 6 and append left onto the deck D. Well, at the deck D at this point looks like no, because this is going to do it all at once. So it'll first save the 8 in the stack, right? And then it'll append that left onto D, and then after popping it off. Perfect. Yeah. Okay. So then that's it. We're just kind of reversing the list, but establishing it back. So now we'll have our list will look like this. Deck D will look like this. 6, 7, 8, 1, 2, 3, 4, 5. Right? Now, while D at index -1 does not equal to 3, we want to push onto the stack the pop value. So this will take the 5, this will take the 5, pop it off, and append it onto the stack. And then, because I have this happening outside of the while loop, it's going to pop all of those. So it's going to pop the 5 and the 4 and append them onto the stack. So our stack will look like this. It's going to take the 5 first and then the 4. So now we can take the 4 off. We can just pop from the stack exactly and append left back onto D. So now our deck will look like this. It's going to take the 4, 5. Oh wait, that's not what we want to do though. Yeah, so we need to no, it's going to take the 5 first. Yes. But we need to append the 5 first. So the 4 has to come out first here on this stack. So if the 4 has to come off first, right? uh, so we append left onto the deck. No, the 4 will come off first and then the 5. So 4 and then the 5. Exactly, like that. And then we'll have 6, 7, 8, 1, 2, 3. Perfect. Just like that. Now, while D does not equal 1, while D at negative 1 does not equal to 1, we want to take from and push onto the stack the popped values off of D. It'll just be a repeat of this line here, and then D dot append left S dot pop, right? So that'll pop off the 3 into the stack, push it back on here, pop off the 2, push it back on here, pop off the 1, push it back on here. And so at this point, but we'll stop on the 1, so we need to do a while S, right? D dot append Q dot pop, or S dot pop. And then we need to return D. So now if we call a print to swap of D1, right, given in our example here, hopefully we get the answer here. Come on. Oh, no. Dang it. So we're getting 2, 3, 4, 6, 7, 8, 1, 5. What is happening here? So let's see. Let's do what we did before. Let's call some print statements. Print D. At this point, let's call a print on D. And then at this point, let's call a print on D. Okay. So I'm just going to run swap here and run that. Oop, there we go. Okay, so we get 6, 7, 8, 1, 2, 3, 4, 5. Perfect. Then we get, okay. So the 5 is not being appropriately handled here. This is where we're messing up. So we are popping off on D the 5 and the 4, and I'm pushing them onto the stack in this order. I'll take the 5. No. Right? So why our 5 is still in our stack for some reason? Oh, because we have 2 numbers in our stack here. So we need to call one more d dot append left the stack dot pop to get that 5 out of there. Right? And now if we run this, we get that 5 happening. Okay, and then we need to say wow, we have the pen left here. That's why. Boom. No? A pen left. I thought that would take off the 1. So now we're not, okay, we're close. We're really close. We just need to get this 1 now. We're super close here. So our 1 is not being popped. Well, it's not equal 1. So it's not getting the 1. We'll say it does not equal 8. That'll do it. And then you just remove this statement. Yeah, that took care of it. Okay, so now we can get rid of these prints. And I believe that this is our final answer. Woo! Yo, we did that. Let's go. Oh, nice. We successfully identified that we had to start from the reverse because we were using a stack, right? Not a deck or a queue. Right? So we can only append and pop from S, and that's exactly what we're doing. Awesome. What do you guys think about this one? Right? Okay, let's throw this into the almighty orb here. See what he has to say. This is my answer to this this problem. Your implementation seems to be solving a problem that involves using deck D and a stack S to rearrange elements of the deck according to the same condition. Here's the breakdown. Initialization. You create a deck D from the input and initialize S as an empty deck. You move elements from D to S, back to D until element is at 5. In the second loop, you repeat a similar process. Third loop. Okay. I think this is correct, right? All right, let's go ahead and move on. All right, round of applause, you guys. Woo! We completed chapter 6. Moving up. Moving up. Super cool. We completed chapter 6. Okay. On to chapter 7, linked lists. Oh boy, oh boy, oh boy. Okay. This is going to be a lot. Here we go. Another new topic here. Chapter 7. Bring this out. Open this up here. Chapter 7 underscore notes dot md. Okay. Hey, Angela Lopez, welcome back. We just finished revising 6.13 here to be appropriate for using only pops on cues rather than using pop lefts or pop Yeah, we rather than using pop at index 0, we're using pop left. Huh. Yeah, you can't pop. Wait, I don't think we can pop left on a Q either. Oh, hold on. Can I not pop left on Q? Your implementation achieves the desired transformation of the deck D using deck Q. You're asking if you can avoid using pop left. The option depends on the logic if you plan to use Q. In your current implementation, Q is used as a first in, first out structure, but at certain points you also use pop to retrieve the last element. This introduces a LIFO behavior which makes Q behave more like a stack in those moments. So the pop left on Q in the third while loop. In this step, you're moving elements back and forth from D to Q. If you want to avoid pop left, you can use the pop instead, but you need to carefully track the order of the elements. You can append and pop consistently. So what they do is they have pop left, pop left, pop, pop left. They do the pop here and pop, and that should return the same thing. No. So while D that was as 0 is not equal 4, we're going to pop left on D, append to Q, append to D, the Q pop, append pop left. So at this stage, Mahan says, did you see the question I sent here? No, I did not. Sorry, where was it? I'm trying to look here. Um, can't you just deck D then NQS? Ooh, ow. So at this point, let's go ahead and I'm gonna bring back my print statements. So print D, print D, D. Okay, so we're getting the 1, 2, 3. We're getting the 1. Oh, what's going on here? Clear. Print. Ooh, whoops. Here. Okay, so we're getting the 1, 2, 3 are getting added to the end, right? The 5's getting added. The deck D in the third print statement is back to normal without the 4. What? So the 4 is in our stack. It needs to get pushed on. So our goal here is just to swap these two values only. We did this successfully for using a stack only, but right? So we swapped the 4 and the 5. But now in problem 13, we can't use a pop left on a Q, right? Originally I had a pop left right here, which was solving the problem. But I can't use a pop left here. I can only use a pop here. And if I do that, it throws everything off. So this is going to take the well, D doesn't equal 4, so it's going to go all the way to 4. Then while it doesn't equal 6, it's going to 6, and we're going to append. Okay, we need one more D dot append Q dot pop here. And will that do it? Yeah. Okay, cool. That fixed it. Perfect. All right, sweet. We found that bug. Get rid of our print statements. There we go. So now if I clear this out, right, our original deck D is 1, 2, 3, 4, 5, 6, 7, 8, and we get 1, 2, 3, 5, 4, 6, 7, 8 now. And we are appropriately calling pop only on the Q, and we're not calling pop left, so it would look like this. We need to do a double. We had to just add one more because just like in our previous problem, we had to add one more as well. Or in our not previous, but our post problem after this. Cool. Because we can't use a pop left on a Q because that defeats the purpose of a Q. So I'm going to take this, I'm going to throw it into the almighty orb here. Your implementation successfully rearranges the deck D to desired order. Let's break it down step by step. Which are 5 and 4 and appends them to the rear. Exactly. Okay, and then if we do this one and give it to it right after. The task requiring to arrange deck D in a specific order using the initially empty stack S. Let's reevaluate. Loops between D and S. Removes until 5 and 4. Correctness. The overall function achieves the desired transformation. The use of the deck operations pop left, and append ensures efficient manipulations. Enhance the readability. So suggested improvements for this one was that we call up to -1, we d.pop, s.append, stack.append. Oh, they would rather have you use a stack rather than s. Okay, that's whatever. d.append left, s.pop. Okay, nothing different there. Nothing different here as well. d.append, stack.pop, while d -1. Okay, cool. So there was really nothing that it wanted me to change. Awesome, we did it right. Woo! All right, I appreciate you guys joining me today. If you're new, please follow along. Please consider throwing a like to the video. It really helps to get other people to get suggested into the ether of the algorithm. So, and I love interacting with you guys. All right, chapter 7 here. Oh boy. Oh boy. Here we go. Okay, let me close up some of my stuff. We got a lot of tabs open here. Is there a hotkey to close them all? Probably. Oh well. Chapter 7 notes. I'm going to pull up my chapter 6 notes so I can just reference the format. Okay, like so. Copy that in. Chapter 7. All right, we're going to be learning about linked lists here, you guys. Linked lists 7.1, which is going to be singly linked lists. Okay. Oh, wait. A Q? Oh, wait, hold on. A Q, we don't want to, we can't pop. This problem's right. I mean, this problem's wrong. Ugh, why do we keep going back and forth on this? So, right, in a Q, we append and we pop at 0, right? With a Q, do we append and pop 0? Yes. Okay. So we had the pop left right on this one. Hold on, let me go back here. Pop left. Okay, so this is what we started with today. So we can't pop, do this. Okay, so with a Q, we can only pop 0. But this is popping at 0 because Q has pop 0, but no append. It has insert 0. No, Mahan, that would be incorrect. You pop 0 and insert 0. You'd be inserting and popping at the same place at 0. You have to add at the end of the line and pop at 0. It does have append. You have to add to the end of the line with append and pop at 0. So we're going to pop 0. This is going to pop. We'll do this inside the loop, pop 0 like that. Pop 0 like that. I think that this should still work now. No. Pop from an empty list here. So no, like that. 1, 2, 3, 4, 5, 6, 7, 8. Blake Goddess, hey, I'm new here. What are you using to study Python? Hey, Blake, welcome in. It's great to have you. Super awesome that you found the channel today. Yeah, we're using data structures and algorithms. For my typical learning style, I like to read books aloud, live on stream audio style, audiobook style, and so I read these books aloud on stream and work through them and break them down, and then I work on projects afterwards. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's call our print statements again. Sorry, this is taking me a little bit. We're still trying to sort this out. Call print here as well. Okay, so we get the 1, 2, 3, 4, 5, 6, 7, 8. The 4 and the 5 aren't swapping appropriately. That's what's happening. Okay, so it's here. So we are popping. So we need to keep this outside of the loop there. SS7IN, when did you start? The problem now that we're facing, what book are the exercises from? Yeah, this is from Data Structures and Algorithms in Python, just like in the title. Um, so now we're getting 1, 2, 3, 4, 5, 6, 7, 8. The 5's getting captured. The 5's getting captured. We're popping from D the 4 and the 5 and appending them onto the Q. So at this stage, the Q looks like 4 and 5. And then we're taking 4 and 5. So this is where we're messing up here. So we are taking, we're popping the 4 and the 5 off until we reach 6. And then we are pending the 4 and then the 5 as well. So that's what's going wrong here. But I can't pop the 5 off. I have to be first in, first out. The 4 was first in. When did I start coding? Yeah, I started about 6 months ago. I started with Harvard CS50P, and then I started this channel after I completed that course, and I've been just teaching myself through books from then on. So I've only been coding for about 6 months, but I really started heavily teaching myself through the books about 3 months ago. So this we're not appropriately, if we call d.pend here again on the same call here, right, you'll see that it's just giving us our same list back again now at the end. So we're capturing the 5 and the 4 in the same order and then just putting them back. But I can't take from the end of the queue. I have to take the 4 first, or I need to load the 5 in first. Oh gosh. Do you think it would be easiest to start from the other side again? Rather than going from left to right, go right to left? Start at the 8 and go down until we reach 5. 5 goes in first. Well, if that's the case, yeah, 5 goes in first, which means it has to come out first. But wasn't that the same principle applied in the other problem? Ooh. Um, so let's try this again. So while D does not equal to 5, D at index -1 does not equal to 5, we're going to take in 8. We're going to d.pop, deck.pop, the 8, 6, and 7 off. The 8 gets popped off, it's get added in. 6, 7, added back in. Okay, so that's fine. Now we'll say while D at index -1, right, does not equal to 3, we're going to take the 5 in, I'm lost. Ugh. We're taking the 5 in and the 4 in. But the 5 has to come out first now. Right? So we pop from the end of the deck and push on to the queue. The queue will have 5 and 4, and so 5 will be removed and appended next. And then the 4 as well. So that's just the same thing is happening. So let's try to go the other way then. So while d of 0 does not equal to 4, we're going to pop left on the deck and take 1, 2, 3 out. And then we're going to append 1, 2, 3 onto the deck again. So now if I run print D here, I'll just quickly write a pass here. Has no arguments. Deck.pop takes no arguments, one given. Oh, this is pop left, right? So we pop left rather than using 0, and you append with Q. Yeah, okay. So in this one, what I do, I appended and popped onto the stack. Yeah, okay. So with this one, you pop left and you append. Okay, perfect. So now, if I print this, we get 4, 5, 6, 7, 8, 1, 2, 3. Perfect. Now we need to, while d at 0 does not equal to 6, we're going to pop left the 4 and the 5. The 4 entered first. So the 4 enters in first, then the 5. The 4 has to leave first, and then the 5. So I'm struggling. I need some help here. Let's see what. To accomplish desired, here's the step by step. Move the elements from Q, reorder the middle section, reconstruct, append. So from transfer. So this is using ranges. So this one said in the range of 3, we're going to pop left to get 1, 2, 3. Temporarily remove 4, push 5 back onto D dot pen left, D dot pop left. Oh. So you need to take the 4. Okay, I see what's happening here. Hey, welcome, Sukrab. I appreciate you coming in. Thanks so much for leaving a message. It's awesome to hear from you. How you doing? Thanks for the kind words and the motivation. Okay, so what we need to do is we need to pop off the 4. So we need to, well, D is equal, right, on this one we need to append the 4 into the queue. We then need to D dot append D dot pop left, right? We need to append the 5 back in the first place. Hmm. The walkthrough killer, welcome. Just coming in. What are you trying to solve? Yeah, we're working on this problem 613 here. We solved it with the stack, but I kept going back and forth and re-implementing this because I was incorrectly handling queues. I was removing from the wrong place. I was treating them like decks, unfortunately, and so I'm trying to rework this so that we are doing, so we're doing 613 right here. This is from Data Structures and Algorithms in Python. If you guys want access to this book, I have a Discord linked below with all of my study resources for all my PDFs, books, notes, everything, as well as we have a lot of members, almost 200 members in the Discord alone, where we have a lot of CS majors that have also put in their resources and everything, so it's really great. Okay, so while D at index 0 does not equal to 6, we're going to Q dot append. So we need, no, 5. So we're going to append the 4. We need to do this. Oh, gosh. I've been looking at this too long. My brain is not sharp here today for some reason. Okay, come on. We got this. Okay, so at this point we have 4, 5, 6, 7, 8, 1, 2, 3. We take the 4 off in this statement here and save it in the queue. We then append so we need to have this outside the while loop. We then append the 5. So now if we call print D here, right? Now we have the 5 coming in, and we need to then do a Q D dot append Q dot pop left, right? So now that should add the 4 back on, perfect. And now we just need to say while D at index 0 does not equal to 1, we're going to say D or Q dot append D dot pop left, right? And then D dot append Q dot pop left, like so. And then, so now if I print here, D, we get 1, 2, 3, 5, 4, 6, 7, 8. Perfect. So now we're going to just return D here. I'm going to remove my print calls in the middle. Oop, whoops. And I believe this solves the problem. Cool, I think that's it. I think we solved it. So now what's going on is with queues, right? So I'll make a note here. Remember, Q's, Queues, um, can only are first FIFO, or first in, first out, right? Uh, right? So we need to say when using the Python deck class as an adapter class for a queue, um, only append or q dot append and q dot pop left are permitted, right? So that's a little bit of struggle that I had before, was I wasn't appropriately managing the queue. I was kind of using it as a double-ended queue, and that's why I had to come back and solve this problem again. Um, yeah, the walkthrough killer. Yeah, it looks like data structures and algorithms in Python. Exactly. Um, it's by Goodrich. Yep, by Michael Goodrich. Awesome. Sounds good, Serpent. You're definitely being productive. That's for sure. Awesome. Sukrab, you just trying to solve problems and learn at the same time. Exactly. Yeah. So for those that are new, I graduated back in 2021 with a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company in the Bay Area, California, and I have been doing that for the past 3 years. I'm currently a mid-level scientist two. Hopefully, going for that scientist three mark this year is my goal. But I make biological controls used in clinical diagnostics and testing for patients and other purposes, and clinical research and things like that. These are products that third-party people, hospitals, clinics buy from the company to do in their testing for whatever purposes. I just make the products, and at first I do pilot scale, and then I expand into mass, like upwards of thousands of liters of scale. So I work with like a lot of biological serums, fluids. I make things like spinal fluid from scratch, like in vitro in the lab, like synthetic spinal fluid. I make lots of serum matrices, like where you have different blends of serums and plasmas. I work with a lot of human urine and um, lots of just biological products. I am a biological, pretty much scientist, chemist. Yeah, which is kind of weird to say, but it's cool. And I'm 26 years. I'm about to turn 26 years old. I graduated back in 2021. And so if this is something, and I've just been teaching myself just to gain new skills, become a more viable candidate, and just also pursue my education more. And rather than going back to school, I thought that maybe I could at least give a good attempt at trying to learn these things from these collegiate level textbooks, right? Because that's really all college is nowadays. And it seems like more and more professors are just getting worse and worse because they're underpaid, and the like the colleges are just like withholding funds and not appropriately paying. And so a lot of these professors aren't doing that great of a job. So why not just bypass the middleman of the whole American collegiate system and just try to learn this myself? I already have a degree, an advanced degree in STEM and science. So if I can try to just gain some additional perspective in coding and have some projects and examples to demonstrate my skills, then maybe I could bring that to the table. Yeah, exactly. So I was, for more specific example, in my daily work, I have to. What actually really sparked this was that, um, yep, I'm a professor, PhD instructor, criminally underpaid. Yeah, exactly. That is my philosophy. It's just like the American education system is really just, unfortunately, it's just I don't know when the light at the end of the tunnel is going to come up. It's just really sad, unfortunately, and really depressing. I mean, people have loans that they have to pay back that they can't even really use to their degree because they can't even. It's just really, it just sucks, man. I feel for people really bad. I got really, really lucky. I'm privileged to say that I got lucky. Like I graduated at the end of 2021, so I just caught that tailwind of hiring frenzy, and So just I just don't blame them though. Like, why would you want to put in that much effort dealing with, students and everything when you're just not getting the reward out of it to even sustain basic life and necessities and enjoy yourself with this higher level education? And so, that with that, unfortunately, I decided to just try my best to grind as far as I could, through these collegiate textbooks, which are all college is just a reiteration of all these previous texts, and then obviously new technology that comes from there. But if we have all these resources, I might as well try my best to learn it first, and then if I really then desire want to go back and get a degree, well, then it'll be just that easier to get that degree because I will already come in with a ton of knowledge. Um, but yeah, it's hard. But to speak to your example, I make, like I said, I have to blend like serums into a various matrix. Like, I can't get into specifics due to confidentiality, unfortunately. But I have to mathematically calculate and predict like theoretical concentrations or effective concentrations of bulks in mass, like solutions in mass. And I have to like analyze over like 50 different, lots of solution that I can potentially use. And then I have to determine which ones I want to pick and choose from. And so it's a lot of just kind of plugging and chugging data analysis. So my goal is to one day develop some sort of program that uses like a randomizer to plug in these values for me and then learns from those values, maybe through artificial intelligence or machine learning, to learn from those like results. Okay, we need to go a little bit higher, we need to go a little bit lower this time, and then fine tune those values and then display them like kind of like cracking a code, or like exactly, it's like code cracking almost is basically what I could try to say. um, and a lot of professors just suck. I agree. Yeah, I have a lot of students that got into computer science because their parents wanted them to go to a viable major, but the thing that sucks is that many of those students don't enjoy CS. Yeah, exactly. That was another one of my reasonings. Was it seems like a lot of students currently, just just a huge flock of students are just going for the money and the monetary values. And I'm really trying to differentiate between that because I'm really enjoying actually coding, right? I also have a lot of people that come into my chats that are CS majors and in college like yourself, and teachers and professors, which is fantastic. I love that you guys are coming in to help me out with this. It's super cool. Please follow along so I can continue to talk to you guys and we can chat and create a big community here. It's really great that you guys are here. But they even tell me that, students that are graduating that they have, or their colleagues, they can't write, haven't written a single project. They just copied and pasted from ChatGPT. Um, like I'm really, really trying to differentiate between that and grind. Like whenever I ask ChatGPT questions, I'll preface like, please don't show me code, or I know I looked at code today because I already had my drafts and I wanted to know where I was going wrong. But if I'm completely stuck, I'll say, don't show me code. Give me some verbal document. Give me some verbal steps and like in pseudocode, and let me try from there. Right? It's really difficult. And so maybe if I can bring projects to the table, I have this channel as physical documentation. Literally, it's a physical video diary series of me learning from zero all the way to wherever I get to, and whatever that may bring, whatever door that opens, I'll walk through it. Maybe I will definitely try, or at least consider walking through it. Maybe, but um, yeah, whatever happens happens. But I really enjoy just streaming and learning this with you guys for now. So that's kind of what I'm focused on. I was doing that, and now I can't find a next job. I'm horrified, terrified, paralyzed state of mind. I'm a PhD student, so no. Hey, Muna, welcome. Third year. Oh, okay, cool. If the state of academia recovers, I might be able to secure a professorship when I graduate. Yeah, hopefully we get some job influx, but it's the H1B visa situation. It's getting interesting. I'm not gonna get into politics on this channel at all. We're gonna keep this straight to learning, but it's difficult when political things start to actually affect your workforce, right? So it's just hard. But let's just keep focusing on the learning. Let's stay positive. I want to, that's the whole point of this channel, was to remove that competitive aspect of, oh, I need to find a job. I need this. I'm going to beat this person out because I already do have a job in another field. So, whatever does happen here, it's just icing on the cake, right? That's just unfortunately for my situation, and now I'm not. It's not for others, and I feel for others, but for my personal situation is I do have employment and I already have a degree in an outside science field, and so or a physical science field rather, and so I do have that going for me, and I'm able to sustain myself that way. And then I'm privileged enough to be able to treat this as a hobby, where some people are maybe having to view it as forcing themselves to do it to secure work. And I'm trying to I really want to make this enjoyable and reflect that through the stream through just cup half full, right? Um, I was doing postdocs and now I have no step. So I have to change field and find a job. Yeah, academia is tough right now. I think a lot of colleges are struggling with hiring professors right now too. Walkthrough Killer says, what are your thoughts on using ChatGPT in CS classes? I teach CS2, so I explicitly disallow it. My reasoning is that students don't know what they do and don't know, and also don't know how to learn. Yeah, so I will give a little bit of feedback on this just because I do have to use it as a pretty main resource. Um, I think that it's fair for you to disallow it in your classroom because the students have the opportunity to go to you as a superior. The format of this stream is completely peer to peer. I really wanted to establish that from the start, that this is a peer to peer learning experience where you and I are most for the most part equals in this, where whatever I'm learning and whatever I happen to learn, if you do learn from that, great. I am not here to teach anything. I am a student myself trying to teach myself this. And if I do happen to get misinformation, I would really hope that you guys would help correct me on that, or the AI would help correct me on that. But I'm using verified, solidified textbooks with accurate information, and then I'm cross-referencing that with AI to help break things down. But I will preface, I always, I have been saying since I've been doing the stream, I will preface the AI to not show me code. I think it's very slippery slope to slip down when you just start copying and pasting and not understanding what's going on. If it does show me code and I do actually need it to show me code, I will literally read it line by line, word by word, and break it down to see what is happening loop by loop, everything. And then I also will challenge the Chat GPT to, dive deeper and see if it has flaws in its reasoning and things like that. But for my specific example is I kind of have to use it. It would be wrong. It would be unwise, and I think a handicapped for myself as an independent learner to not use it. But I do have to use it in a responsible way. It's the job of a professor to teach students how to learn when they're just starting out. Many students use AI as a crutch and not as a supplement to their learning. Exactly, exactly. Where they have that resource of you, which they should be going to you. Unfortunately, I'm in a little bit different situation, so I'm using the AI as my resource to then go to ask further questions to elaborate. But in no circumstance would the teacher ever just give the student the answer to cheat on, and so that's the same mindset I have. I am not going to use ChatGPT just to give me the answer because at the end of the day, it doesn't help anything. It does not help anything. If I get a job in that field and I've used AI the whole time, I'm just going to look dumb. I'm just going to feel stupid. I'm going to have imposter syndrome, and it's just not going to be a good time, and I'm probably going to burn out. Um, Plus, I do already have a job in a physical science field in chemistry and biology, so that just allows me to take that pressure off and really treat this as a hobby and something I really want to get better at genuinely. I really want to learn this inside and out because I really enjoy it. It's not a pressure at the end of the day. Wing Hong, it's a nightmare as my next position doesn't exist and I have nothing after all these years. Yeah. Um, Sorry, there's lots of chats. I'm getting caught up here. Sorry, guys. Um, Sometimes it skips my place and I have to find where I left off at. What region in the US are you from? Midwest, maybe? I don't think I've heard someone with your accent before. Yeah, I'm from the Pacific Northwest. Was born and raised in Oregon. I kind of look like an Oregon guy. uh, from what people look like there. But I went to school. I graduated from Utah State University, Northern Utah, just in a small, not a small, it is a smaller town in like the Utah canyons up in the mountains in the snow. It was really fun experience. My mom played collegiate sports there, so I was able to get an out of state tuition deal, and it just seemed very financially responsible to go there, and just it set myself up, well for financial reasons and things like that, rather than taking out loans and stuff. So just for my circumstance, and everyone's is different, but I went to Utah State. I graduated in 2021 with a BS in human biology and a minor in chemistry. I was an undergraduate teaching fellow for the chemistry department for my sophomore, junior, and senior years, and then I was the for the general chemistry department, and then I was the undergraduate. I was the only undergraduate lab instructor with the graduate group for the general chemistry lab classes, where I solely administered labs and graded homework for all the undergraduates as an undergraduate myself. So I was really, really involved in the chemistry department and wanting to learn that as well. And so, yeah, that's my experience in college so far, or back then. Um, but I currently reside in the Bay Area and work in the Bay Area for, because that's just where all the biotech stuff's at. Here, like, what is it? Is it Michigan? No, it's Boston. It's Boston and Boston, Massachusetts. Yeah, I think it's right. My geography is so bad. Yeah, I don't. I'm not Bay Area. I definitely have a. I've been told that I do have like a slight um like a Pacific Northwest accent. I'm not exactly sure what that means, but it's definitely I've been told that before. I get extremely depressed sometimes. Well, Wing Hong, don't man, you gotta take that pressure off yourself. You're gonna lead to burnout just in any sort of field if you keep that kind of pressure on yourself. You need to. I often think that it's difficult because you want things to come to yourself, but and it's also difficult to let things come to you. But you strike that balance, right? And you can't force things either. The universe works in kind of crazy ways too. So I don't really have too much advice, but just hang in there, man. It's tough. Just come hang out with us. Let this stream be kind of a chill, just take a load off environment where you don't really have to stress out. Hopefully that we can make this kind of like that. Uh, I have 12 TAs and a class Discord, and yet they insist on using AI to get out of doing the work. Yeah. If anything, it's just gonna hurt them. People get what they ask for. Unfortunately, karma comes around sometimes, and uh, it's gonna be a rude awakening. Unfortunately, when they have to really step up for these to actually get jobs in their fields. So. Uh, that's all that you can really kind of cling to is at the end of the day too they're paying for the class and they are adults, so that kind of is their decision, unfortunately. But it kind of sucks though too on the other hand, because they're getting a degree that other people have that actually really put in work for, but yet they're kind of at the same ranking because they have the degree, kind of. And so it's that's tough too, definitely. um Academia is broken. Yeah, it's definitely tough right now. That's why I kind of opted out of going back to school right now. I'm not an expert, but as a student interested in education, using a tool like GPT in a self-learning context where you truly want to learn is different than being in a classroom setting. Yeah, in a classroom, there's incentive for it to just do all the work for you. Exactly. Exactly. I don't have a test at the end of the semester that I'm pressured for. There is no pressure here to rush through this material. College, unfortunately, and with computer science as well, computer science is rapidly evolving year after year. AI is new. So that's just more classes that are having to be added on to the curriculum. And so the students are just being spread so thin, I bet you, that they might just feel they have to it's they might just not physically have the capacity to take in all of those informations, from machine learning to AI to basic coding to software development to front end to back end to computer science on a hardware level to physical computers to whatever else there is out there, networks to security. Like there's so many topics. Unfortunately, it's unlike any other major because it's still so rapidly evolving. It's evolving faster than any other curriculum probably, and so they're just spread so thin. So maybe they just are by default feel like they have to. I see that's the correct way to do it. Plus, you said that you already have a degree in there and therefore discipline. Most 18, 19, 20-year-olds don't have that discipline to resist from just copying. Yeah, that is a very true statement as well. I would be dumb to say that if I didn't, use some sort of help or like, obviously when I was 18, 19 and back in high school, like you just don't see things truly as what they are, that this is for your benefit. Like if you skip over things, it's only going to hurt you. You just don't have that kind of development and mindset yet. Just one says self-studying with ChatGPT when used right can exponentially increase the rate at which you learn. Yeah, exactly. Well, if you look at this channel for example, you guys. I know I have a degree in biology and chemistry, but 6 months ago I had never seen a line of code ever. Right? And so, but yet we've already written two whole projects. We're writing a third project. We've read over two entire textbooks, completed over 100 practice problems between the two of them, successfully, like mostly on our own. Like we are just rapidly improving here, and we probably will plateau soon enough where we start getting slower and slower because the material's getting harder and harder. But it just goes to show that this can be done, and that's what the whole point of this channel is. I wanted to demonstrate that we can teach ourselves these things. We can be responsible. We can be determined, and this is not something that we have to pay $50,000 a year for, right? Hopefully, if we're just curious, right? The humans are just curious by nature. Guidance from the elders. What is your goal with Python? Would you want a CS job? Um, I'm not sure, right? I currently work as a formulation chemist. Guidance from the elders. Thank you so much for comment. I appreciate you joining me this evening. It's the first time I heard your name, so it's great to have you here. Join the Discord below so we can chat offline and you can get access to all my resources. Um, but yeah, so my goal is just to maybe further intertwine them in my current field at first and then expand from there. That's probably a good way to start. But just, I want to learn. Thanks so much for coming in. Just one says, I build custom GPTs for specific topics I'm about to learn. Oh, cool. Yeah, I don't have much experience with AI yet. We do have a book here that we're going to get to on the channel. We have Python machine learning, so we're going to get to this one soon enough. And we also have Fluent Python, so we're going to read these ones on the book channel. We've already read, when we were doing our learning Python crash course, we read this one live on the channel and did all of the practice problems inside. I'm also currently going back through and just uploading video solutions on the channel, my channel, for these practice problems. They're pretty easy, just beginner ones to help out the beginners on the channel, because still am, right? Yeah, so we'll get into those eventually, but right now we're doing DSA in Python. Sorry guys, I'm talking a lot here. All right. We got a lot of chats. You guys are awesome. John Davila says, no, no, not the Mormon college. That is a BYU down south in Utah. I went to Utah State University, just the state school in Utah. Got a really good, got a scholarship there for some alumni because my mom went to play some collegiate sports there. So it was a good financial deal, and it just made sense to go there. I really wanted to go to University of Oregon though, where I was, because I'm from Oregon, but it just didn't work out, unfortunately. But it's okay. I had a great time. Yeah, exactly, Muna. Yeah. Yes, Pratik, thanks so much for your message. This book is in my Discord. I have a channel just dedicated to this book where I have the resource, the PDF provided there. Um, it's my dream to get a job in CS. Oh, that's an awesome goal to have. I really hope that that comes true for you, man. Thanks so much for coming in here. Also, as a side note, if you're looking for resources, I'd recommend How to Design Programs by um, Felician et al. Don't pronounce that. It teaches functional programming via the Racket programming language. Oh yeah, walkthrough killer. Feel free to post a link or something or a reference in the Discord because I don't think the YouTube chat lets you post links or anything. So if you want, feel free to post that in the Discord and I'll check that out. I'm currently adding resources that we're going to go through on the stream for sure. Wish I could understand the accent. I myself have a Middle Eastern. I wish I could. No, you're. I bet you. I like. We all are born in different places, so we guys got to roll with what we got, right? Just a chill guy, Spency. Yeah, that's right. I try to be, right? Just a chill guy. Thanks so much for your comment, Spency. Appreciate you coming in. It seems like that you're being. This is something that up from trying to become a software engineer. It seems like to be employable, you have to spread yourself thin on many technologies. I want to master a few things deeply. Yeah, that's exactly what my philosophy too, Muna, is that. I'm not trying to collect programming languages like Pokemon gym badges. I played the crap out of Fire Red on my Game Boy growing up, and I had pretty much every Pokemon going up until Heart Gold, and then I kind of fell off when I got older. But um, a big Pokemon guy here. Yeah, I'm not trying to collect languages like gym badges or the Pokedex, right? I'm really trying to master one language and then expand from there because taking in those additional languages after you have a mastery in one would just exponentially be way faster, I bet. Um, you guys are awesome with the chats. I appreciate you guys chatting with me so much here. I wouldn't recommend going to college for IT, honestly. I know one too many people who work for tech giants in great positions who got through it just being really good at what they do. Oh, okay. If you want a ton of practice problems, I recommend my own book. It's on LiveGen. If you don't want to buy it, Learning Java, a test code driven approach. Oh, wow. That's really awesome walkthrough. Yeah, I've never read any Java or looked at that. So I'm currently kind of looking at Python mainly for right now before expanding out. But we've also been given some suggestions to look at C and C++ to help solidify our Python knowledge because it would definitely help just our general programming knowledge for those languages. So for those that are here in 2025, Harvard CS50 is going to be revamping their X course, which is more like their full stack computer science course. And so we're going to be taking that live on the channel together in 2025 in just a few days. Um, Praddick says, by the way, I'm new here and I enjoy the vibes from the stream. Looking forward to see more of, and let's interact on Discord. Oh, awesome. Thanks so much, Praddick. I appreciate you coming in. Exactly. That's what this is for. Let's get the lava lamp shaking up here. Let's get these vibes really going here. Ooh, look at that. Yeah. I need to get a bigger lamp. um, Jared Arms says, hey, bro, keep it up the awesome work. Thanks so much for the comment, Jared. Appreciate you coming in. Uh, Thank you, walkthrough. I'll check it out. I can't agree with you or disagree with your thoughts about uni, but as a student from the University of Toronto, I can say I can say everything is in uni is good, maybe because it's number one in Canada. Oh, okay. Yeah, I'm not really familiar with Canadian colleges, unfortunately. Just the U.S. ones and the feedback we've been given in the chat here. Okay, cool. So that was a lot of comments. Thank you guys for interacting with me here. But we got these two problems fixed, right? So in this first problem, 6.13, our task was to take a deck D that has these values in it, 1, 2, 3, 4, 5, 6, 7, 8 in that order. And we were to use only a Q and use it as a Q, right? Variable Q. And use the variable Q to kind of offload these values onto and perform and result into this the deck into this value here where the 5 and the 4 are swapped. So what we did was if our deck looks like this, right, we have if our deck while our deck at index 0 does not equal 4, so we will continually iterate up through the not iterate, but we'll just kind of like peak or whatever at these values up until 4. We're going to perform these actions at, like through this while loop. We're going to remove from pop each one of these off from the left of the deck and append them onto the queue, and then we're going to just append them back onto the deck by popping left onto the queue. So at this stage we'll have 4, 5, 6, 7, 8, 1, 2, 3. Then in this one where we need to do the actual swapping, so we're going to save the we're going to do save the 4 in the queue, but then we're going to pop the deck, the 5, and append it directly on, and then we'll put that 4 on. So this was a line of code that I didn't really understand. I needed to implement, and this is kind of the solution here, was that we had to append, pop on D and directly append back onto D before putting that 4 on. That will cause the swap there. And then obviously until we get back to our original place, we're just going to do the same thing as in this while loop above, and then return D. And so as you can see, we get appropriately the deck 1, 2, 3, 5, 4, 6, 7, 8. And then in 6.14, we wanted to do the same thing but use a stack instead of a queue. So for stacks, sorry, that was my dog, just scratching. For stacks, you guys, we were we can only append and pop from the end, right? We can't pop left or anything like that when using the deck adapter class, right? Because Python doesn't actually have a stack class. So we use the deck adapter class, but we need to understand that we can only pop and append from the stack. So I decided that, well, if we can only do kind of the reverse of what we did before, let's actually start from the end of the array rather than the beginning. So we start from the end of the array, pop off values, and bring them onto the beginning, kind of in the reverse sequence, because it just made sense with the stack. And then we were able to create a stack with 5 and 4, pop each one of those off, 4 coming first, 5 next, and then we get the value of the result that we were looking for of 1, 2, 3, 5, 4, 6, 7, 8 for this one. So we solved these two problems here. As a challenge, you should implement a stack as a Python class. Yeah, that would be a good, definitely. I know that they provided an example of one. They wrote a literal stack array class. They wrote a queue one, and then they have a stack one up here, I believe, as well. So that'd be a good a practice one to implement our own and then verify via the stack, right? We would need an initialization, a length, an is empty, a push, a top, which is the reference, and then a pop function as well. So we could definitely do that as well. All right, let's keep moving on here into linked lists. All right, we're moving on, guys. Sorry, we had a lot of chats here, but I appreciate you guys commenting, making this a lot more interactive. You guys are awesome, awesome, awesome. For those that are new here, feel free to throw a like if you're enjoying the content, enjoying hanging out. It really helps to get other people to get filtered into the algorithm and get other people in the community, and it just also helps keep the motivations going. It's great to see that you guys are enjoying the stream and enjoying the content. You guys always tell me you guys are enjoying it, so it's awesome having you guys here. All right, let's continue on here. Well, I'll ask you guys. Would you guys prefer if we continued on into chapter 7 and did some reading for today, or should we should we shift focus into our project? What do you guys think? Should we start off with a little bit of reading into chapter 7, or do our project, which is our small business manager? What do you guys think? What would you prefer to see? I'm fine with whatever. The project that we're working on, pardon me. So the project that we're working on is the small business manager. So we currently have a class for items where we initialize some attributes, pretty basic attributes such as item number, names, item size, cost, date created. We're importing the date time module here to actually capture dates as well. We have some additional optional parameters here that get overridden and applied when the item is actually converted into these categories. Of when I'm kind of inferring, rather than having a flag for saying that the item is now for sale or sold, we can kind of infer that the item is for sale and sold based on these attributes if they're filled in or not. So if it has a date listed and a listing price, well, it's obviously for sale. And if it has a date sold and a sold price, well, that's obviously sold. So that's how we're determining those rather than having additional flags here. Now we do have an active status flag here. I created this and implemented this active status flag to work as I never wanted someone to actually be able to physically remove an already logged item from the database as a whole, like completely remove it, because that would leave a gap in our item number sequence, right? Because we continually increase the item number as items get added into the system, just dynamically how we've written it, right? So if we were able to remove an item from a system, well, it just causes the possibility that maybe something could go wrong or just leaves that gap. And I didn't want to leave the gap once an item is logged, but now to actually like have it not be kind of considered anywhere in the system, you can set the active status to false. So then it won't be read in basic like statistical operations for like, you know, these were all the items that are still available versus sold for the end of the year, right? Where if we don't want to include active false items in those statistical business, statistics, then we need to have a way. But I didn't want to actually remove the item physically to create that gap in sequence. Now, this also allows like a safety feature where the person can then come back and maybe add it back on. Like such as, for example, if the item just cannot sell and they're like, okay, I'm just gonna just take a loss on this one and just set it to false. So yeah, but this is the project that we're working on. We've been writing. It's completely in the CLI interface. I've only written projects that work in the terminal. So far, I haven't actually written any full stack applications that have a front end on the internet or anything like that. I'm not quite there yet. That's a big endeavor with only the amount of time I have after my 9 to 5 job. But uh, I'm partial to data structure, so I'd vouch for doing linked list stuff. Oh, gotcha. Yeah, so the whole purpose of these projects is just to like reinforce those concepts that we're learning in the books to actually make sure that we're practicing coding, practicing like actual implementing, not just solving basic problems to either based on a prompt, but actually seeing how they would maybe work in like a system and stuff like that. So eventually, my goal is to have like the user be able to transact all these items, right? Be able to convert them into sold items, convert them into for sale items, and then have reports given to them. These are the items that are for sale for 2024. These are items that the revenues for 2024 versus 2023. All these types of different reports that can be generated and displayed. So that's kind of like my goal, and then just to have this be like more of a tool for small businesses. It's basically a small business manager for inventory and sales and tracking that. So yeah, but it sounds like people want to continue going on with the linked list, so I'm perfectly fine with that. Okay. All right. Let's continue on here. In Chapter 5, we carefully examined Python's array-based list class, and in Chapter 6, we demonstrated the use of that class by implementing the classic stack, queue, and deck abstract data abstract data types, ADTs? I can't remember. Python's list class is highly optimized and often a great choice for storage. With that said, there are some notable disadvantages. The length of the dynamic array might be longer than the actual number of elements that it stores. Yes. The amortized bounds for operations may be unacceptable in real-time systems. Okay. Insertions and deletions at interior positions of an array are expensive. Yes, we know that. Because you have to increase the index values from either end of the insertion, from the right onwards of the insertion, right? Or from right onwards of the deletion. In this chapter, we introduce a data structure known as a linked list, which provides an alternative to an array-based sequences such as a Python list. Both array-based sequences and linked lists keep elements in a certain order, but using a very different style. An array provides the more centralized representation with one large chunk of memory capable of accommodating references to many elements. A linked list, in contrast, relies on a more distributed representation in which a lightweight object known as a node is allocated for each element. A lightweight object known as a node is allocated for each element. Each node maintains a reference to its element and one or more references to neighboring nodes in order to collectively represent the linear order of the sequence. We will demonstrate a trade-off of advantages and disadvantages when contrasting array-based sequences and linked lists. Elements of a linked list cannot be efficiently accessed by a numeric index k. We cannot tell just by examining a node if it's the second, fifth, or 20th node in the list. However, linked lists avoid the three disadvantages noted above for the array-based sequences. Ah, interesting. All right, singly linked lists. Here we go. Let me pull up, how do I format these ones? We did a definition and then examples. Okay. So here we go. We'll do like this. Singly, I like this word, singly linked list. All right. A singly linked list in its simplest form is a collection of nodes that collectively form a linear sequence. Each node stores a reference to an object that is an element of the sequence, as well as a reference to the next node of the list. See figure 7.1 and 7.2. Example of a node instance that forms part of a singly linked list. The node's elements member reference an arbitrary object that is an element of the sequence. The airport code, MSP, in this example, while the next member references the subsequent node of the linked list, or none if there's no further node. Okay. So here's our head. Oh, these are thinking of like destinations, like in a plane. For example, a singly linked list whose elements are strings indicating airport codes. The list instance maintains a member named head that identifies the first node of the list, and in some applications, another member named tail that identifies the last node of the list. The none object is denoted as the not symbol. Right? Is that not? I think so. Wait until you get to doubly linked list. He likes the word singly. Yeah, doubly. All right. Let's keep going here. Let's get a definition going here first, though. So we got singly linked lists is a collection of nodes that collectively form a linear sequence. Each node stores a reference to an object that is an element of the sequence, as well as a reference to the next node in the list. Okay. Now that definition is kind of interesting. We'll hopefully it breaks it down. All right, the first and last node. Okay, so hold on. We'll need a how did I format this other one? I did examples. All right. 1, 2, 3. So then we'll say like here we'll say like this. No, we'll go below the examples, I guess, and go here and do a head and a tail. So a head, the first and last node of linked list are known as the tail and the head of the list respectively. The first node in the linked list, right? And then the last node in the linked list, okay? By starting at the head and moving from one node to another, by following each node's next reference, we can reach the tail of the list. We can identify the tail as the node having none as its next reference. This process is commonly known as traversing the linked list. I don't know how to say that. Traversing. So, basically, it's kind of like, I guess, like recursion. Like you reach a base case of where you have none for the next reference, and then would you like ascend back up, or is that just a property of recursion? Um, because the next reference of a node can be viewed as a link or a pointer to another node, the process of traversing a list is also known as link hopping or pointer hopping. Okay, so this probably is important though. So we'll say traversing. I'll actually put it up in the definitions column like we had before in chapter 6. So we had a like so, and then we'll put this guy here and say traversing is the starting at the head of the linked list, reaching the tail where the next reference is none. We have two link slash pointer is because the next reference of a node can be viewed as a link or pointer to another node. Okay, that's fine, whatever. We'll just leave that there and come back to that one. That's technically the empty set symbol, but it can be used as null slash none. Oh, empty set. Okay. It just means that the last element in the linked list does not have next node, which makes sense because it's the last. Exactly. I would say that a node is the element in the list. It comprises the data. I would say that a node is the element in the list. It comprises the data and the reference to the next element. The book gives an odd explanation. Yeah, so I think along what you were saying, walkthrough, is that the book talked about in chapter 5 when we talked about um, array-based sequences was that um, the array itself in memory does not contain the physical objects in memory, right? The array is independent of its size from their object references. The object are referenced elsewhere in memory, are saved elsewhere within the system's memory, but we just have a reference applied into the array itself. So the only thing that impacts the array's size or memory capacity is how many available slots in total, whether filled or not, the array has. That determines the overall byte size capacity of an array. Whereas the references or the objects are saved elsewhere in the system's memory and just applied references into the array. I bet you if you had the actual objects in the memory, managing those physical data objects in the memory would probably be extremely costly, and that's probably why they do references, is my guess. But that's probably why it's saying that it is that reference because the book already explained that the objects are physically saved elsewhere in memory, not within the list itself. But yeah, it's like it can kind of be applied as like thinking if you're not actually thinking about it from a hardware standpoint that the elements in the list, right? It would be. Mono Usagi, that's pretty impressive that you're teaching yourself Python after your 9 to 5. Keep it up. Thank you so much for those kind words. I appreciate your explaining your kind words. Thank you so much. Hold on, let me go back up really quickly, chapter 5, and see what. Um, See, like right with here, like we did a physical act like the dynamic arrays and amortization, right? We the we tracked the byte size capacity as we increased the size of the array, but the objects in the array didn't change the capacity of the array itself when doing this example, right? It just showed that the array was dynamically increasing with the capacity of the array, but not the reference of the objects itself. from what the book tried to explain. It would be very expensive to store the actual object in the array rather than a reference. This is why pass by value with structs in C is much more expensive than passing it by pointer. Okay, so I think we're on the same page, walkthrough killer, right? I think we're right, yeah. If you guys are enjoying the stream, please follow along. I love having you guys here, helping me out, talking with me. It's awesome that you guys enjoy, being here. Um, but I appreciate you guys joining. Please follow along. Join the Discord below. Yeah, thank you so much, you guys. But list is different from linked list. Linked list is a directional graph like data structure. Okay. Okay, we'll keep that in mind. Yes, an array-based list is very different from a linked-based list or a linked-based. Okay. So does that property not apply to linked list? Are linked lists just references at the node? Do they actually contain? Now, I'm not actually sure. I'm sure we're going to see how these are implemented, but I don't have any actual example of how to write these or anything. Hmm. Okay. All right, let's continue here. Inserting an element. Oh, hold on. Okay, here we go. A linked list representation in memory. Okay, here we go. A linked list representation in memory relies on the collaboration of many objects. Each node is represented as a unique object, with that instance storing a reference to its element and a reference to the next node or none. An object represents the linked list as a whole. Another object represents the linked list as a whole. Minimally, the linked list instance must keep a reference to the head of the list. Without an explicit reference to the head, there will be no way to locate that node or indirectly any others. There is not an absolute need to store a direct reference to the tail of the list, as it could otherwise be located by starting at the head and traversing to the rest of the list. Okay, hold on. Let's pull up the whiteboard. So, is this like, let's say that you have like your memory here. Let's say you have your RAM, right? Your random access memory. It's like it traverses on some line here, right? Let's say you have an object here, right? You have object A, you have object here in memory, B, and you have object here in memory, C. Does a linked list, rather than creating a list of object references A, B, and C, does all this do, rather than doing that, does all this do is create like a current element. Like we'll say current equals to A. Next would be B, right? And then, which this saves also as head, right? So rather than creating a list, are we just creating like links to memory addresses within the system? And are we just tying those together saying, okay, this is not the data point we need. Let's go look at the next one and jump to the next data point and reference that rather than tying all of these into a list and creating an arbitrary number of memory usage in a list. An element of a linked list is generally a dynamically allocated object. You add links dynamically, unlike an array-backed list. So yes, for the most part, elements of a linked list are just objects with the data that at that node and a reference to the next node. See, consider a list of 1, 2, 3. So each element there has an ID in memory. 1 has, I don't know, ID 1, 2 has 1, 2, 4, and 3 has ID 555. Also, our list has an ID, for example, 444. Now the way we save data is ID 4. Got you, okay. In index, okay. Yes, and for arrays, okay, so what you guys are saying then is for an array like ABC in our memory, right? If this is our RAM, in this example, our memory, oh sorry, if our RAM is like this, we would have objects A, B, C all right next to each other in the memory. And then this itself would have a bound on it for a list which has some sort of X capacity memory as well. So rather than creating a third party list, why don't we just kind of hop from memory spot to memory address within our system and then apply, okay, if this is not the element we're looking for, let's go to the next one that's the reference. Well, we're at the tail, so now we need to go back up. Right? And the thing that is important to understand is that the elements are not contiguous in memory. Yeah, so we would have like element F here, or element uh, F1 or F2, right? Where these elements are broken up, but these are not included as nodes in the linked list. Where if our nodes started as like A, went to B, went to C, like this, right? If F sub 1 and F2 were not included in our linked list references, we'd be skipping over them. With an array-backed memory, you know where each element is in relation to every other element. A linked list has no such guarantee. So that's why we can't iterate, because when we had the initial memory here, we could iterate because we know that we can just go move one value to the next. We can iterate over the values of the list. Where now we can't iterate, because if we were to try to iterate, we'd hit this F1, which is not a part of our linked list definition here. Does that sound right? I know I'm getting all jumbled up here. We got a lot of writings going on. It's got a lot of chicken scratch here, but with an array-backed memory, you know where each element is in relation to every other element. A linked list has no such guarantee. Oh, with an array-backed list, yeah. Wait, array has it back to back, but list has it all over the place. Okay, interesting. So I think we're on the right track here. Um, However, storing an explicit reference to the tail node is a common convenience to avoid such a traversal. Storing an explicit reference to the tail node is a common convenience to avoid such a traversal. Hold on. There is not an absolute need to store the direct. Hold on. We skipped over some. Another object represents the linked list as a whole. Minimally. Oh, okay. So in our example here, on our memory here, we would have our linked list referenced here, which houses this thing here. Okay. Um, Without an explicit reference to the head, there would be no way to locate the node or indirectly any others. There is not an absolute need to store a direct reference to the tail of the list, as it could otherwise be located by starting at the head and traversing to the rest of the list. However, storing an explicit reference to the tail node is a common convenience to avoid such a traversal. In similar regard, it is common for the linked list instance to keep a count of the total number of nodes that comprise the list, commonly described as the size of the list, to avoid the need to traverse the list to count the nodes. For the remainder of this chapter, we will continue to illustrate nodes as objects at each node's next reference as a pointer. However, for the sake of simplicity, we illustrate a node's element embedded directly within the node structure, even though the element is in fact an independent object. Okay, yeah. So in these examples, they're showing that these nodes, like these values, are directly, within these nodes itself, but remember, these are just references elsewhere in memory. The linked list as a whole is memory as well. You're on the right track, Michael. Awesome. Thank you so much, walkthrough. Appreciate you. Thank you so much. Okay, a compact illustration of a singly linked list with elements embedded in the nodes rather than more accurately drawn as reference to external objects. Okay, so this is the element itself and then has a reference pointer to the next. So each of these spaces in memory would take up two sections of like bytes in a sense. Is that accurate to say? Not accurate, but like on the right track, I guess, because you have two like you know byte boxes here, from my understanding, that which is the element itself and then the reference to the next element, the pointer. I see. This is a term overloaded. By quote elements, I mean the boxes themselves. The data at a node is the stuff of interest. Lax MSP. The reference at the node is the next node in the list. Okay, yeah. So we have two spots here. We have the data itself and the reference to the next node. But I don't think the data itself is housed in this linked list. It's a reference in itself, but for simplicity's sake, they're just demonstrating it in this form. Oh, what the heck happened? Ooh, quit. Oh, whoops. That was weird. Let me pull that back up. Data say. Okay, that was weird. Crashed for some reason. Okay. Both objects will be next to each other in memory. Got you. Okay. You're using elements to refer to the data at the node itself. Yeah. Okay. Inserting an element at the head of a singly linked list. An important property of a linked list is that it does not have a predetermined fixed size. It uses space proportionally to its current number of elements. It does not have a predetermined fixed size. It uses space proportionally to its current number of elements. When using a singly linked list, we can easily insert an element at the head of the list, as shown in Figure 7.4, and describe with pseudocode in 7.1. The main idea is that we create a new node, set its element to the new element, set its next link to the reference to the current head, and set the list head to point to the new node. So we have a head of MSP. We can set a head. Okay. Insertion of an element at the head of a singly linked list. A is before the insertion, B is the creation of the new node, and C is after the reassignment. Okay. So algorithm, add first L and E. Newest equals node at E, which creates a new node instance storing reference to element E. Newest.next equals linked list.head. Set new node to the reference to the old head. L head is equal to newest. Set variable head to the new node, and then size increases by 1. Okay, inserting a new element at the beginning of a linked list, L. Note that we set the next pointer of the new node before we reassign the variable L head to it. We set newest.next is equal to L.head. So this is the newest equals new node at element E. Set new node's next reference to the old head. Okay, so setting the newest value, the next reference is to the previous head value. We then reassign the head value to the newest, because we need to capture it before we reassign it and then increase. Exactly, okay. Inserting an element at the tail of a singly linked list. We can also easily insert an element at the tail of the list, provided we keep a reference to the tail node, as shown in Figure 7.5. In this case, we create a new node, assign it to next reference to none, and set the next reference of the tail to point to this new node. and then update the tail reference itself to the new node. We give the details in code fragment 7.2. So in this case, we create a new node. Exactly. We create a newest node. We assign the next value reference to none to set it that this will be the tail. We take the linked list current tail next value is equal to newest, right? Because the next value is no longer equal to none at that tail. We set the tail equal to the newest and then increase the size by 1. Exactly. Cool. Removing an element from a singly linked list. Removing an element from the head of a singly linked list is essentially the reverse operation of inserting a new element at the head. This operation is illustrated in figure 7.6 and given in detail in code fragment 7.3. Let's get caught up on some chats here. Right, unlike an array which has a fixed size and is resized when filled, a fixed capacity more so. Exactly, it has that dynamic resizing happening within the system's memory itself via some factor of ×2 or whatever it would be baked into the language. Wing Hong says, wait, so each memory allocation in the disk is 2 items, a value and the next. Yes, I think so. So, hold on. I don't think it's the value, right? It's the reference to the value and a reference to the next value. So let's say we have our linked list L, right? We have our RAM down here, right? We have some value A, right? So A is a reference. Reference to object A is added as a node into our linked list, right? Which then has a reference as well, a pointer to ref B. So A itself, this pointer in value, I think is are these as well. Now, is it a reference to the object or is it a reference to the memory spot? White Gold 251, bro is looking into my soul. I've got some dagger blue eyes that just peer into you. I can really open them. It's just kind of, you can see the whites in my eyes. I don't think it's advantageous to think of the data as a reference. Just think of it as the data itself. What if you had a linked list of numbers? Sure, those might be references to numbers in memory. It just doesn't hurt to think of them as being numbers in the list. Pointers are to node. Okay. Removing an element from the head. So if we want to remove LAX, what would we have to do? We'd have to say that the head, we have to set head next is equal to head, like here, and then decrease size. Exactly. Okay. But they said if L head is none, then indicate an error saying the linked list is empty. Okay. Meaning that there was only one value in the linked list. You got to do that check. Okay. Unfortunately, we cannot easily delete the last node of a singly linked list. Even if we maintain a tail reference directly to the last node of the list, we must be able to access the node before the last node in order to remove the last node. But we cannot reach the node before the tail by following the linked list from the tail. The only way to access this node is to start from the head of the list and search all the way through the list. But such a consequence of link hopping operation could take a long time. If we want to support such an operation efficiently, we need to make our list doubly linked. See, as we do in section 7.3. Oh boy. So what that said was that, right, what that referenced was that if we have a linked list of A to B to C, or we'll do it like this. A to B to C, right? If we wanted to just remove the tail, we couldn't do that. We couldn't just directly be like, okay, let's take our RAM and let's go find node C just right off the bat in like an O of 1 time, right? That would not work because we would have to first start at the head, traverse to B, then traverse to C. And that would cause some sort of, you know, n operation time based on how many, the size of the actual or linked list. So we cannot, that's what it's saying is, yeah, we'd have to get a reference to this one before to set this as, as tail, right? Just think of it as a node as a storage block with a sticky note to the next one. Gotcha. That's a good analogy, Ben, too. Thank you so much. A node is one of the boxes in that diagram. A node contains two things: the data at the node and a pointer / reference to the next element of the list. We make a node, and a node has a data and a pointer, which points to the next node. Okay, yes. So each node, so think of like this, right? A node is the physical circle itself and the arrow coming off of it. That is one node, right? Then we have another node to the next one, right? This is another node, right? Sorry, I'm using a magic mouse. It's hard, right? So these in themselves are nodes, right? And these are just references. If this is node B, this is ref to node B. This is ref to A, right? If this is ref to B, or object B. In a sense, you could just think of it as object B. This is ref to object C. Now, what is the reference? That's my question, guys. What is the reference? Is it the like a peak, like a you can't index to, right? Is it a peak at the next value, or is it the memory address for that byte location in RAM? Um, Node for singly linked list, 2 numbers. Double linked list is 3 numbers. Okay. See, the problem is you need to think outside of the box. Now we're making object that has those 2, not just the tuple list. It's completely different. Usually the node stores a reference to the data rather than a data set, but it's not really helpful to think in that way. Yeah, exactly. So when we're talking about like the object itself, it's just a reference to the object, hence why I have it crossed out here. It's just easier to think that the node itself is the object, but when you're actually thinking about the memory location, it's a reference because it's saved elsewhere in the RAM. The linked list as a whole, right? This linked list as a whole is saved in the memory in the RAM somewhere, right? The linked list is somewhere itself. But we have references to A, we have reference to B, we have reference to C, but in between those we have reference to F, we have reference to Z, right? We have all these other ones, but we're hopping from these points with this linked list, which is all encompassed within this one memory allocation. Okay, I think so. References are memory addresses. Okay. Pointers, memory addresses, references are all the same thing in my eyes. It's the memory address, and Python skips a step so you aren't dereferencing it. Yes, the linked list stores references to head and tail and size number. Okay, cool. Thank you guys. You guys are awesome. Okay. All right, I think we'll go for about another 10 minutes. I'll probably wrap it up around 10 o'clock. We've been streaming for almost 2.5 hours so far. So we'll go for another 10, 15 minutes here. Just wrap up this last little bit on singly linked lists, and then yeah, and then we'll just wrap that up for today. So thank you guys for coming in for today. We'll do 10 more minutes here, and stick with me here for the last little bit. Okay. 7.1.1, implementing a stack with a singly linked list. In this section, we demonstrate the use of a singly linked list by providing a complete Python implementation of the stack ADT. In designing such an implementation, we need to decide whether to model the top of the stack at the head or the tail of the tail of the list. There's clearly a best choice here, and we can efficiently insert and delete elements in constant time only at the head. Since all stack op There's clearly a best choice here. We can efficiently insert and delete elements in constant time only at the head. So would the head at of the list be at the end? Right? Is it inverted, right? Because you want to be able to pop and append at the head, and so you would have to be at the end of the list, right? Of the stack. Um, since all this is clearly There's clearly a best choice answer, we can efficiently insert and delete elements in constant time only at the head. Since all stack operations affect the top, we orient the top of the stack as the head. Okay, perfect. Cool. Guess that. To represent individual nodes of the list, we develop a lightweight underscore node class. This class will never be directly exposed to the user of our stack class, so we will formally define it as a non-public nested class of our eventual linked stack class. The definition of the underscore node class is shown in code fragment 7.4. So we have this node class, which has in some dunder slots. It's non-public because it has a underscore in front of the node. Dunder slots is equal to an underscore element string reference and underscore next string reference. And then we have initialization, which takes in the instance itself, has some element applied to it, and a next feature for the next node. Okay. A node only has two instance variables, underscore element and underscore next. We intentionally define dunder slots to streamline the memory usage. See page 99 of section 2.5.1 for discussion, because there may be potentially be many node instances in a single list. The constructor of the underscore node class is designed for our convenience, allowing us to specify initial values for both fields of a newly created node. A complete implementation of our linked stack class is given in code fragment 7.5 and 7.6. Each stack instance maintains two variables. The underscore head member is a reference to the node at the head of the list, or none if the stack is empty. We keep track of the current number of elements with the underscore size instance variable, for otherwise we would be forced to traverse the entire list to count the number of elements when reporting the size of the stack. The implementation of a push essentially mirrors the pseudocode for insertion at the head of a singly linked list as outlined in section code 7.1. When we push a new element E onto the stack, we accomplish the necessary changes to the link structure by invoking the constructor of the underscore node class as follows. So self.head is equal to the node E self underscore head. So it gave reference to element and then the self head. Note that the underscore next field of the new node is set. Ooh. Woo. Thank you. Sorry, guys. Sorry if that was loud. Note that the next underscore next field of the new node is set to the existing top node, and then the self underscore head is reassigned to the new node. So we have some chats here. It's memory. Okay. Yes, the linked list stores references to the head and tail and size numbers. If you store references to the head and the tail, it doesn't matter which you push/pop from. You can efficiently insert and remove elements at either end, so it's just up to you. Hey, Evil, thanks for coming in. I appreciate you leaving a message. Just learning for fun. Just trying to improve. I have a degree in human biology and a minor in chemistry. I work as a formulation chemist, so I'm just, keeping myself, keep learning new skills. It doesn't help to, learn how to program. It just, life, you can do whatever you want in life, right? All right. As long as you're not hurting someone else or causing problems, right? There's no, it's not against the law to teach yourself to program. It's just for fun. Appreciate you coming in. Okay, so we have a linked stack class. We have a class node, right, which is what we had before, where I forgot what the dunder slots does. In Python, dunder slots is a special attribute you can define in a class to explicitly declare a fixed set of attributes that instances of the class can have. By doing so, you can save memory and prevent the creation of arbitrary new attributes, as it eliminates the need for default instances dictionary dunder dict. Memory without dunder slots, each instance of a class has a dict to store its attributes, which takes up additional memory. Slots replaces the dict with more memory efficient structure. Restricted attributes. With dunder slots, you can only define attributes listed in slots. Attempting to reassign attributes. Okay, so it just creates a fixed, like a fixed dynamic dictionary. So that in memory, just right off the bat when initialized, rather than having them be filled in later on, right, or something like that. And then you can't create more. Like you can't have the user override to create more. I don't think either. Thanks so much for the message. Yeah, awesome. Thanks for coming in. I appreciate you. Okay, so we initialize a dunder slots where we say that these are the only two instances of attributes that are going to be applied to this node class. That are for memory usage. Okay, these are our stack methods. So we say that the size is equal to 0 when we're initialized. And the head is equal to none. We assign head if we push to that value of the node at E and increase by 1. Okay, but so you assign a head value when you push an element and increase its size. When you assign the head, you create a new node with the element itself with a reference to the head as its next element. So you're creating heads over and over again in theory, but just going down the line and just, I guess. And then if you pop is empty, stack is empty, answer equals self.head._element. Okay, this is getting tricky quick. When implementing the top method, the goal is to return the element that is at the top of the stack. When the stack is empty, we raise an exception as originally defined in code fragment 6.1 of chapter 6. When the stack is non-empty, a self._head is a reference to the first node of the linked list. When a stack is non-empty, a self_head is a reference to the first node of the linked list. The top element can be identified as self._head._element. Okay. Our implementation of pop essentially mirrors the pseudocode given in code fragment 7.3, except that we maintain a local reference to the element that is stored at the node. So the answer is a local reference, and we return that answer here and decrease the size by 1 if we pop. Yeah. We return the element of the color of pop. Yep. The analysis of our linked stack operations is given in code in table 7.1. We see that all methods complete in worst case constant time. This is, in contrast, amortized bounds of the array stack that were given in code fragment in table 6.2. Okay, so all of these are happening because we're using the stack now, all in one O of one, rather than having the amortized, push and pop happening for that dynamically increasing array. It defines instance variables for the class. Yeah, that's the Dunder slots. Okay. Okay, implementing a queue with a singly linked list. 7.2 circular. Okay. Okay, we'll just finish 7.1. As we did for the stack ADT, we can use a singly linked list to implement the queue ADT while supporting worst case O1 time operations. Because we need to perform operations on both ends of the queue, we will explicitly maintain a underscore head reference and an underscore tail reference at instance variables for each queue. Because we need to perform operations at both ends of the queue, we explicitly maintain a head and reference. Okay, got you. The natural orientation for a queue is to align the front of the queue with the head of the list and the back of the queue with the tail. Because we must be able to enqueue elements at the back and dequeue from the front. Recall from 7.1. Recall from introduction 7.1 that we're unable to efficiently remove elements from the tail of a singly linked list. Our implementation of the linked queue class is given in code fragment 7.7 and 7.8. Okay, so same thing, node. So in our initialize, we have a head now and a tail now. When we return a reference to the element at first. To dequeue an element, if it's empty, raise an error. Except we save answer as the head of the element. Self underscore head is equal to the next. We set the head to the reference of the next element, and we decrease the size by 1. If we enqueue, we would set the head to the newest if it's empty. Else we set the reference from the tail to the newest. Set the tail equal to newest. Oh, if you're adding an element to the back of the queue. Got you. Okay, cool. Many aspects of our implementation are similar to that of this linked stack class, such as the definition nested in underscore node class. Our implementation of dequeue for linked queue is similar to that of the pop for linked stack, as both remove the head of the linked list. However, there is a subtle difference because our queue must accurately maintain the tail reference. No such variable was maintained for our stack. In general, an operation at the head has no effect on the tail, but when a dequeue is invoked on a queue with one element, we are simultaneously removing the tail of the list. Therefore, we set self._tail to none for consistency. Right here. Right? If we dequeue we set it to none here if it's empty at that point. Okay. In general, the operation at the head has no effect on the tail, but when dequeue is invoked on the queue, okay, there is a similar complication in our implementation of enqueue. The newest node always becomes the new tail, yet a distinction is made depending on whether the new node is the only node in the listed class. In this case, it also becomes that the new head. Sorry, I'm all over the place. There is a similar complication in our implementation of enqueue. The newest node always becomes the new tail, right? When you add a new element to the end of the queue, it becomes the new tail. Just like if someone gets in line, right? Yet, a distinction is made depending on whether the new node is the only node in the list. That in the case, it also becomes the new head, right? If the list is empty and you insert one element, well, it becomes the head and the tail. Otherwise, the new node must be linked immediately after the existing tail node. In terms of performance, the linked queue is similar to the linked stacked in that all operations run in worst case constant time, and the space usage is linear in the number of current elements. Woo! Okay, I definitely need to go back through and take a little bit better notes on singly linked lists for sure. Um, I definitely need to go back and take some better notes on here, but yeah. Hey Harry, I appreciate you coming in. How are you doing today? Welcome, welcome. How are you doing? Unfortunately, you're just coming in at the tail end of the stream. I've been streaming for 2 hours and 40 minutes so far. So I am going to wrap it up for today. I've got work tomorrow, so I'm gonna just kind of probably just watch a show and hang out with my dog, take her out, and then get to bed here within the next hour or so because I got work tomorrow. But for those that are new, my name is Michael. Thanks so much for joining me today. I have a Bachelor of Science in Human Biology and a minor in Chemistry. Um, I graduated from Utah State University in 2021. Right after graduation, I got a job as a formulation chemist for a biotech company, and I've just been teaching myself to program for the past 6 months to further increase my skills as a scientist, as a candidate, as a person, and as a student. Right? I'm gonna forever be a student. No matter what. I'm always gonna be learning things, teaching myself things. It's one of my main hobbies. If this is something that is very interesting to you, or also in a similar situation, or you just enjoy hanging out with me, please follow along. I love to interact with you guys and talk. It's honestly so it's really cool that you guys are interacting and joining me on this journey. I have a Discord linked below in the description where I provide all of my study resources from the data structures and algorithms in Python PDF I've been reading aloud on stream all the way up through chapter 7 so far, to Python Crash Course, which I already read on stream, to books that we're even going to read in the future, such as Fluent Python and Python Machine Learning. So all of these books we will get to eventually, hopefully on the channel in time, and we're going to, continue to learn and just solidify our learning. Eventually, we're going to branch into probably C and C++ due to some recommendations to just further intertwine our Python knowledge and general CS knowledge. And in 2025, we're going to be starting up the Harvard CS50X course, which will be revamped in 2025 per their new curriculum. So, and we're going to be live streaming those. We're going to be live streaming those lectures and my live watch-alongs of the lectures onto the stream here. So I'll be posting announcements in the Discord. So thank you so much for joining me today. DSA in Python is wild. Are you just talking in general, or is this book hard in your opinion, or are you just what do you mean? Madar, hey, what do you do as work? Are you currently you want to do programming? Yeah, so I work as a formulation chemist right now. Like I said, I have a BS in human biology and a minor in chemistry, and I just am learning to further improve my skills and I'm a forever student. I have always been interested in computers and programming just in general, but I've never actually gotten around to it. So for the past 6 months, I've been teaching myself. I started with Harvard CS50P, the Python course, and then I have just been reading books independently, continuing my knowledge, working on projects independently, such as the Small Business Manager that we've been building on stream. We also built an entire task tracker project, which is currently live on my GitHub if you want to check that out. I will say that I will say that looking back at this program that I wrote for the task tracker, it definitely could be improved. What happened here? Why is it doing this? Let me save this here. Hold on. Task tracker. Yeah, so I rewrote this entire task tracker project live on stream a few weeks ago. Whoops. Sorry about that. What was it? Command. There we go. Right. So this one is just a basic task tracker. I'll give a quick demo of this one. This one was really easy. It's just like yes, and it gave you just cute little prompts with the imported Causa module. It displayed expired tasks and tracked those as time progresses in the future, and you reopen the program. It was a really cool project that's on my GitHub. I will say that I didn't really handle the data structures all that well in this project. I hadn't read anything about data structures. This was all just my own creativity going into this. So I had a lot of instances where things were being intertwined from my actual my actual script to my data structure class, and so I was having a lot of problems, making changes or implementing features because I was having to go back and change a lot of things between files. So moving forward into our small business manager project that we've been working on, I've learned from that and kind of more distinguished that the data structure should be kind of independent and uh, right. So this shouldn't be here. I don't know why that's there. Right? So the data structures should be kind of more independent and universal rather than, and then I'll have more of all the organization and storage of those datas within our script itself and into a more main dictionary structure aspect. So, which made things more compatible back and forth, which definitely helped. So I appreciate you guys joining me today. For those that don't know, I'm a formulation chemist. I work Monday through Friday, nine to whatever, a normal 9 to 5 job. And then I teach myself Python afterwards. So I stream every day, Monday through Friday, even on weekends, Saturday and Sunday. I have a streak going so far. I think we've been streaming over probably like 20 days live. Not all day, but just we come back every day, and we have a good streak going right now. I teach myself from around. I usually hop on around 7 p.m. PST, maybe around 6:30. Sometimes if I'm a little later at 7:30. But I usually try to stream for about 2 hour, 2.5 hours to anywhere from 2.5 to 3.5 hours every day, and really try to learn this stuff. And I'm really dedicated. So if this is something you're interested in, please follow along. I love having you guys here. I've been grinding away. I started this channel 3 months ago. We've already passed 600 subscribers. I really, really appreciate you guys, supporting me and really enjoying this. Join the Discord link below where I have all my study resources and everything. But yeah, so for the past 3 months, we've really, really been kind of shifting into taking this seriously and trying our best to grind through this and enjoy it along the way. It's really fun. I get a lot out of it, and it's definitely something that I want to keep doing. And yeah, so anyways, I really appreciate you guys joining me today. I'll see you tomorrow around 7 p.m. PST. Please join the Discord. I'll talk to you guys offline there if you have any more questions. And yeah, cool to see people getting into programming, especially with the AI boom currently. Respect. Yeah, no, this is I don't really I don't really care about the whole AI thing. If it does happen and it does, whatever, I don't really care. I'm gaining new skills. I'm getting smarter, in my opinion. I'm sharper. My mind is thinking about things. I'm solving problems in more abstract ways. It's definitely just helping me as a student as a whole. I'm teaching myself proper study habits. It's just helping me as a human being as a whole in general. So definitely, and it's there's no pressure in this. It's all for fun. I enjoy doing this. It's for fun. It's for the stream and for our own independent learning. So I'll